Okay, I want to go ahead and get started because we got a lot to do and to try and get through and stuff today. So I just want to make sure you guys have a chance to kind of ask the questions that you need to, and we're going to go through a lot of things off of this objectives review. Remember, you can find this in the module that says final exam. And there's the part that says preparing for the final exam and then taking the final exam. So this is something that you'll find in that part about preparing for the final exam. A couple of things to just make sure you're aware of. Remember, you will have 2 hours, and this is a comprehensive test, so that means that it could cover anything that we talked about this semester. So also it's going to be 20 questions. All right, it's usually 25, but we shortened it to 20 this semester. And also remember, you can use one sheet of note paper, right? So one 8.5 by 11 sheet of paper with notes on it. Okay, and so usually you have to, have everything memorized and stuff, but the department decided to allow you to do that because I know a lot of you, were not intending to have to learn kind of online and stuff, and so hopefully this will kind of help with that. So you'll notice on the first page of the objectives review that it does kind of go over some formulas and things that you should know. And so I would say anything that's on here that you don't have memorized already, I would say that would be a really good thing to make sure that you put on that sheet of paper that you're going to be making to use on the test. And remember that you're going to be uploading that sheet of paper also with the work that you're going to be doing on the test. So, and then you'll have 2 hours to complete the test, but then you'll have an additional hour just to get things, uploaded and stuff. I know sometimes for some people, if your internet's not as fast or something, it might take you a little while to get those uploaded. So you'll have a full hour after you've submitted your final to upload that work. But you need to make sure that that work that you have on the test and the answers that you gave on your test match. Because if those don't, there's going to be some issues and you might have to deduct some points and stuff. So just make sure those are the same. Don't change anything on your written work after you complete your test. Okay? Are there any questions that I can answer on that? Just about the final in general? Also, you will not be using Proctorio, right? So some of you have asked about that. Please make sure you read the announcements that I sent out about it. We are not using Proctorio anymore, so you don't need to have a webcam available. It will be similar to the way that you've been taking tests already, so it should be fairly similar. You'll take the test and then you'll upload your work, just like you've been doing in the past. Okay, but if you don't upload your work, I have to mark those questions wrong. So it's really, really important to make sure you show work on every single problem. Okay. All right.
Before you get going, on the final, I had signed up to take it at the testing center. If I do it there, do I still have the 2 hours? And instead of uploading the stuff, do I just turn in my papers?
Yes, that's correct. You'll be receiving just a paper test instead, and so you'll just be turning that in.
Okay, thank you.
Yep. Yeah, so, because some of you may have signed up to do it face-to-face instead of doing it, and some of it was because of Proctorio or whatever reason, but that still is an option for you to do if you've already signed up for it. If you haven't, they've already kind of made all of the assignments and stuff. So if you haven't signed up for it already, you're going to need to get on and do it online. If there are any issues with that, please talk to me about it, okay? All right, so a lot of good formulas here and stuff that you need to make sure that you know. I'm not going to go through every single question on here because there's, you know, almost 70 questions on the subjectives review. And, you know, you'll notice that there is a key also that you can use to check your answers on these. But I wanted to work out some of the type that students tend to have, you know, more of an issue with, and maybe some things that tend to show up on final exam more often, right? To try and clue you into maybe where you should be spending your time studying, okay? All right, so let's so I want to go down and I mean, a lot of the stuff in Module 1, that's this on this first page here, is a lot of review from 980. And so typically they don't ask very many questions off of that first page on the final exam. However, it could show up on there, you know, like maybe trying to, you know, evaluate this function where you have to put, you know, a number into that function. That could, you know, show up on there. But we're going to be doing one a little bit later that kind of deals with that as well. So I'm going to skip over that, and I'm going to start here on the second page, and I want to look at number 5, right? So remember that when you're trying to determine the slope and, you know, the X-intercepts or Y-intercepts and stuff, I want to make sure that you remember you've got to change this into the y equals mx plus b form. So let me rewrite this equation over here. And so if we solve for y, if we get y by itself, that's going to put it into the form that we want. And then I'll need to divide by 4 here. All right, so then y equals, well, 2/4 reduces to 1/2, so 1/2 x plus 15/4. All right, and so when it's in this form, something important to remember is that the slope is the number in front of our x when it's written in this form, and then the y-intercept, right, is the other number there. Okay. And so just something to keep in mind when you're, you know, dealing with these types of linear equations. Okay. Let's go down a little bit further here to number 7. Maybe let's focus in and try and work out this part D. Okay, so it says, write an equation of a line containing the point 3, -3 and is perpendicular to this line that is given here. Right, so let's first look at this line, right? So just like we did above, we need to figure out what the slope is, so I need to solve this to get y by itself. So I'm going to subtract my 2x over. So 5y equals -2x plus 4, and then I need to divide by 5. Right? And so, just like I said from before, right, my number in front of my x when it's in this form, what happened? Hold on a second. My screen just went blank. And here, I don't know what I touched. Just 1 second. Let's see the... Alright, try this again. Sorry about that. Oh goodness, I tend to have these problems when I'm dealing with WebEx and this for some reason. Okay, I'm going to have to try and do this a little bit differently since for some reason it is not liking that PDF, me writing on that PDF. And I swear, these technical difficulties sometimes drive me crazy. Alright, no, I'm so not used to. Okay. Try and take a deep breath here. See if this will work. Okay. Alright, hopefully you guys can see that now. It's just not as big there, but hopefully that will work out. I'll just have to do my work over here on this OneNote part instead. So, okay, so let's go back up to where we were. So we were looking at number 7, right? So part D. And so on this, we want to, so let's go back to, we were trying to solve this 2x plus 5y equals 4. And we're trying to solve it for y because we want to figure out what the slope of this line is. I need that in order to do this. Right. And so then my slope is going to be that negative 2/5. But I want the slope that's perpendicular, right? So this is a little symbol for perpendicular. So the perpendicular slope is going to be the negative reciprocal of this. So that means we need to flip it and change the sign. So it's going to flip to be 5/2, and instead of being negative, it's now going to change to a positive. So that's the slope that we want to use in the equation that we're going to be writing. And then also it gives us that the point we want to use, right, is going to be that 3 comma negative 3. So you could use the point slope formula. So I think that's the way a lot of the students were doing it, but there's a couple of different ways you can do this. And I'll show you both ways really quick just to make sure that everybody is good with it. So with the point slope formula, right, that says y minus y1 equals m times x minus x1. And so I just need to put these things in that I know. So y minus y1, which is, whoops, I put y2, y1, which is negative 3, so minus a negative 3 is going to be plus 3. And then my slope that I want to use is 5/2, and then x minus my x1, which is 3, so x minus 3. Right? And so this is one way that I can do it. I'll show you the other way in a second, because I know some of you may not do it this way. But then from here, we need to distribute that 5/2 through. So we get 5/2 x minus 15/2, right? Because I'm just doing that 5/2 times negative 3 over 1, right? To get that negative 15/2. And then I need to subtract my 3 over. So if I'm subtracting 3 from this, then it really means I need to get a common denominator, right? So let me put this as kind of like 3 over 1, right? So my common denominator is going to be 2. So I need to multiply the top and bottom by 2. So that's going to give me 6/2 there. And then I still have that 15/2 on the top. Right? And so then it's negative 15/2, right? And then minus 6/2. So that's really going to give me a negative 21/2. So let's see what we have here. Let me try and write this down here. So I've got y equals 5/2 x minus 21/2. Right? So usually on the final exam, they don't give you a lot of things with a lot of crazy fractions, but some fractions could come up, so it's always a good idea to make sure that you know how to deal with those. Okay? What questions do you have on that one? Make sure you're speaking up if you have some questions, or type something into the chat so I know if I need to clarify anything for you there. But that would be our answer. This is the equation of a line that goes through this point and whose perpendicular slope is 5/2. Okay. All right, let me see. Let's get down to talking about these systems of equations. Now, on the test, they'll usually just tell you to solve the system, but they won't really tell you which way you need to solve it. It'll just say solve the system, right? And so on number 10, that's what we're looking to do, is just solve some of these. And I want to go ahead and do kind of, I guess I'm going to call this B on that second one, right? So I'll call it 10B, I guess, right? Which asks us to solve 4x minus 5y equals negative 23, and 5x plus 3y equals negative 1. Okay? Anybody have an idea of where we would start to try and solve this system? Be willing to speak up?
Are we doing it by the elimination?
Sure, yeah, I would do it by elimination since that's kind of the way it's set up here. What would you do first?
I think I would, I don't think it really matters which variable you choose, so I would just probably do x.
Okay.
And I would multiply the top by negative 5 and the bottom by 4.
Okay, right, because you need to make sure that whichever variable you pick to eliminate, right, and you're exactly right, it doesn't matter which one you choose to eliminate first. But so on this one, you just need to make sure that one's going to be a negative and one's going to be a positive, right? So if I write these out, then you're going to need to multiply that negative 5 through, right? So I'm going to have negative 20 plus, or right, negative 20x plus 25y equals negative 23 times negative 5. So that's going to give us negative 1, or sorry, positive 115, because we have a negative times a negative. All right, and then on the bottom, if we distribute that 4 through, we get a positive 20x plus 12y equals negative 4. And then you can see that we eliminated our x's. That's what we were trying to do. But we need to add our y's together on this. So that's going to give us 37y equals 111. Right? And then we just need to divide that by 37. Right? It might not look like it divides in evenly, but it does. So y equals 3. And I'll just tell you, on these type of questions with this solving the systems of equations and stuff, usually the answers come out to be whole number answers. So if you're coming up with some weird fractions or something like that, then I would say double check your work, make sure that you didn't forget a negative or something somewhere, because that's usually the mistake that tends to be made on this. Okay, so I know y is 3, so remember I'm going to write my answer as an ordered pair. So 3 is going to go here. And now I need to solve for x. And I can solve for x by putting 3 in place of y into either of the two equations. I'm going to choose the bottom one here to put it into. So I'll have 5x plus 3 times 3 equals negative 1. So 5x plus 9 equals negative 1. Let's subtract the 9 over. So 5x equals negative 10. And we divide by 5, we get x equals negative 2. So my ordered pair would be negative 2, comma 3. Right? So just remember, you know, like, doesn't matter which way it asks. I mean, it's going to just say solve, and you're just going to be able to solve it in any way you want to. Okay? All right, let's look at one of these story problems here. Sometimes these mixture problems tend to be an issue for some people, and also the airplane or boat type problems. So let's take a look at those on number 11. And usually it's just being able to get these set up in the right way. Right? So Elizabeth is a pharmacist at a local hospital. She receives an order for 350 milliliters of a 30% antibiotic solution. She has a 15% and a 50% solution, but does not have a 30%. How much of each of the solutions must she mix together to get 350 milliliters of the 30% solution? All right, so I always like to draw a little chart to organize my information here. And the things that I'm going to be putting along here is what I'm mixing. And then down the side, kind of looking for the labels on there. It's going to kind of help you to be able to do this. So the things that we're mixing together, right? We see that she says, hey, I need a 15% solution, right? And she's going to mix it with a 50% solution. And we want to get a total, right? The end result needs to be that 30% solution. So those are the things that we're mixing together and what the total is. Down the side, we see, oh, it gives us milliliters. So when I'm talking about labels, I'm looking for units, I'm looking for stuff like that. So I know something about milliliters, I know something about percentages, and then the total. Okay? And now I can fill in what I know, right? So when I'm asking myself, okay, do I know how many milliliters of the 15% solution I need? No, that's what I'm looking for, right? The very last sentence, right? How much of each of those solutions must she mix together? So I don't know how much of this, 15%. I don't know how much of the 50%, but I know that I need a total of 30%. And how many milliliters? It says 350 milliliters, so I'll put the 350 here. Okay. And in the second row, I'm just changing my percents to a decimal. So I just move the decimal back 2 places, so 0.15, 0.5 or 0.50, however you want to write that when you're moving it back, and then 0.3. Okay. And then the last row that I have here, I'm going to make it by multiplying the top 2 rows together. Right? So x times 0.15 is 0.15x, and then this would be 0.5y. And now I need to multiply these together, and that tends to be where people forget, is that they got to multiply those together. So 350 times 0.3 gives me 105. Okay, and now I have my 2 equations I need. So I have x plus y equals 350, right? This is all with the milliliters. I don't know how much of the 15 or how much of the 50, but I know all together I need 350. And then my other equation is going to come here, right, where I have 0.15x plus 0.5y equals 105. Okay, and then from here you can solve it using the substitution or elimination. It doesn't really matter which way, but since we did elimination on the last one, I'll just go ahead and solve this one by substitution. So with substitution, we need to get one of our variables by itself, right? So if I'm looking at this top equation here, if I subtract the y over to the other side, all right, then I'll have x equals 350 minus y. And so that's the same thing, it's just organized in a different way, right? So I have x by itself, and then I can take all of this and substitute it in place of x in my other equation. Right? So I'll have 0.15 times x, which I'm substituting in that 350 minus y, right? Then plus 0.5y equals 105. Okay, let me give you just a couple minutes, and I want you to try and finish solving this out. What do you get for y? And then plug what you have for y back in to figure out what x is. Okay, so go ahead and try and work it a little bit on your own there.
So I have a question.
Yeah.
So like that first sentence is basically, it kind of confuses me
Okay.
because it's saying like she receives an order of a 30% solution. So like she already has it.
No, so she, like, it's like a prescription came in for her to fill
Oh,
that
okay.
she needs
Okay.
a 30% antibiotic solution, but she only has a 15 and a 50.
Okay.
Yeah,
Okay.
that is, I can see how that's kind of confusing. It's like, what? When she receives it, it kind of, yeah, it just kind of like, it just means like she receives like a prescription that she needs to fill.
Okay. Thanks.
Yeah, you bet. Okay, so did you guys get 150 milliliters for the 50% solution? And then to figure out how much of the 15% solution, right, let's go back to that x plus y equals 350, right, that first equation there. And then to figure out what x is, we can substitute 150 in place of y. And so we get x equals 200. So we need 200 milliliters of the 15% solution, right? And it's really important to not get these mixed up. It seems like on tests, you know, students get 150 and 200, but sometimes they accidentally put them in the wrong blank. So make sure that you are being very careful with which one you mean what, right? Because, you know, I mean, it makes a difference on this. If they need a 30% antibiotic solution and, you know, they got this mixed up, right? They did, you know, 200 milliliters of the 50 and then 150 of the 15% solution, she's not going to end up with a 30% solution like she needs. Okay, so just make sure that's kind of clear there on that. Other questions on that type of question, you know, where we're trying to, you know, mix something together and we have to do two equations and two variables on that. Okay, let's see. All right, let's look at the one right next to it, the airplane one. It's still part of number 11. All right, I wish they had these numbered like A, B, C, D or something, but the other one on number 11, so an airplane can fly 90 miles against the wind in the same time it takes to fly 110 miles with the wind. If the wind speed is 25 miles per hour, what is the speed of the plane in still air? All right, so first of all, it's really important on this to remember that when it's talking about, right, we're dealing with this distance equals rate times time is the formula that we need to know for this. And when we're talking about rate, the rate on this is the speed of the plane, right, plus or minus the speed of the wind. Right, so that's kind of where a lot of people get stuck, is just not remembering that the rate is comprised of two different things there. But again, let's make a little chart here. Right, so we know that we have some information about with the wind, and we also have some information against the wind. Right, now let's look to see what we can fill in here. So the distance, well, it looks like 90 miles against the wind, so I'm going to put 90 here, and 110 with the wind. Okay, but notice it says in the same time. So that means that the times are equal, right? We're going to come back to that idea in just a minute here. Right, and let's see what we know about the rate. Well, we know that the wind speed is 25 miles per hour, but we don't know what the plane speed is. So basically, when I'm dealing with the wind, that means it's pushing the plane faster. So I'm going to have the plane speed plus 25, because it's pushing it 25 miles an hour faster than the plane is actually going if there was no wind. right? And against the wind is slowing it down. So that would give us the P minus 25, slowing it down 25 miles per hour, right? And then this is where a lot of times people get a little stuck too, is because they're like, okay, all they say is that the time is the same. And so you've got to come back to, remembering about this formula, right? Distance equals rate times time. Well, if I want to know what time is, let's solve this equation for t, which means I need to divide by r. So distance divided by rate will give us time. So that's exactly what I'm going to write in here. So I know the distance with the wind is 110, and the rate is p plus 25. All right, so I'm doing that distance over the rate. And then the same thing against the wind, distance over the rate, but this time it's going to be 90 over p minus 25. Okay, and now that I know I can, have these times kind of set up, and I know that they have to be the same, I'm going to set those two equal to each other. Okay, and so now you can see, we did talk about when we had a proportion like this, we can do just cross multiplication, right, to solve it. Let me move this up a little bit, so a little more room. All right, so I'm going to do 110 times p minus 25 equals, now the other diagonal, 90 times p plus 25. Okay, let me give you just a minute or two to figure out this. Okay, so figure out what is our plane speed. That's what we want to know.
I think that should be an addition on the right.
Oh, okay, thanks. Because I was like, wait a minute, what's going on? So let's see if we have, oh yeah, right here. That's right. Okay, so I was looking at that going, wait a minute, that's going to make that negative. Thank you so much, David. And I was like, did I get this backwards? All right, so I came up with the plane speed is 250 miles per hour. Is that what you guys came up with? So, remember, I mean, there could be, different types of problems like this, but any of these kind of application ones over here would be good to kind of look through just to make sure you know how to do those type. Okay, can I clarify anything on there for you? Number 11. Make sure to speak up or write in the chat if you can't speak up with where you're at. I understand that. But one other thing that I wanted to clarify as well, if you remember back on, when we started the semester, on the syllabus, it does say that your lowest test score, right, your lowest exam score could be replaced by what you get on the final exam. So, say that you, did bad on one of the tests, you got like a 65% or something, and you were so bummed, right? But then you get an 85% or something on the final exam. Well, that 65% will change to an 85%. And I will not lower your score. It will only be there to help you. If you do better on the final exam than one of your test scores, it will change that test score. Okay, so I just wanted to make sure everybody remembered that, because I know some people are kind of like, oh, gosh, that one test just did me in, right? But all is not lost, right? Do well in the final, and then it's going to help your grade out in 2 different ways. So it could be really good. All right, let's look at number 12 also, solving a 3x3 system. And so on this one, remember, I like to number my equations. And always double, triple check that you've written it down correctly when when you're writing it from the test onto your paper, because it seems like a lot of places people make mistakes is just writing this down incorrectly, like they forget a negative somewhere or something like that. Right, so just be careful there. So I always like to double check, make sure I have it all right there. Okay. And then I need to decide which variable I would like to eliminate first. So can somebody tell me which variable do you think looks the easiest to eliminate? All right, Christina said y. I agree, because you don't have to multiply the equations by anything, right? So let's go ahead and start this out. So if I do equation 1 and equation 2, right, so negative 5x minus y plus 5z equals negative 3. I'll write down equation 2 underneath that. Then I see that my y's eliminate, right, which is what I was trying to make happen there. And then I need to add the other stuff together so I can see what I have left. So I'll have negative 15x plus 6z equals 0, right? And that's okay that it equals 0. Sometimes that freaks people out. But then we'll call this new equation equation 4. Okay? Now go back up to your original 3 and pick 2 other equations, right? So do you see if I do 1 and 3, the y's will eliminate again. And I have to make the same variable eliminate, right, when I'm doing this. So on the second one, if I made the y's eliminate the first time, I've got to make them eliminate the second time. So let's go ahead and write down equation 1 and equation 3 and figure that from there. Okay, so again, my y's eliminate. I'm left with 15x. With 15x plus 7z equals 0. And I'll call this new equation that I've made equation 5. Okay, now what do I do from here? I'm going to put equation 5 and equation 4 and equation 5 together and eliminate. yeah, one of the variables there, right? So I've got to try and eliminate another variable. So, and this one works out nice because I can see that already, without doing any work, right, my x's are going to eliminate. Right? Let me add those together. So that's going to leave me with 13z equals 0. If I divide by 13, it doesn't matter. 0 divided by anything is 0. Okay, now you want to write your answer as an ordered triple, right? So x, then y, then z. So my z is going to be 0. I'll put that in that place. Okay, now I want to do some back substitution. So I know that z equals 0, so I can take 0 and put it either into equation 4 or equation 5 to figure out the other variable. All right, so I'm going to go ahead and put it into equation 5 there in place. So that's going to give me 15x plus 7 times 0 equals 0. All right, so I get 15x equals, 15x plus, what's going on here? 15x plus 0 equals 0. Right, so that looks like I'm just going to end up with x equals 0 again. Right? So that kind of is weird, but don't freak out about that. That's still okay. So x is 0. All right, and now I still need to solve for y. So I take what I have for both y, or that I got for z and x, and I'll put those back into one of the first original equations so I can solve for y. And it doesn't matter which one I put it into. Maybe I'll just put it into equation 3 here. All right, so I can scroll this down and we can see it a little bit better. So I'll have 20 times x, which is 0, plus y, plus 2 times 0 equals 3. Well, that's just going to be 0. That's just going to be 0. So I'm just left with y equals 3. So I'll put that in place of y. And so there is my ordered triple. Right? 0, 3, 0. Right. All right, you guys sure are a quiet bunch today. Can't tell if you're doing good or not. All right. Please speak up if you have some questions. You're not going to be the only one with that question if you have one. Okay. All right, good. Thanks, Christina. I feel like somebody is out there. So far, so good. It's hard. It's really different trying to teach like in this method because I'm so used to seeing you guys' faces and so used to being able to, you know, interact with you and stuff. So it's just so different for me to do this, but hopefully you're doing okay with it too. All right, so let's look at, I want to skip down and maybe do, actually let's do number 14. Let's make sure that we remember a few things here. So remember, if you see the word and, that is meaning that we want to find the intersection, and that's the overlap, right? And then if you see the word or, that means you want the union, or that means like the set, or, you know, both sets together, everything in both sets. Okay, so on number 14, if we just look at that first one, it says x plus 5 is less than 9, and, right, so this is my word I need to know, 3x minus 1 is less than 2. Right, so I'm going to solve each of these separately and then graph them on the same number line so I can see what's going on. And since it's an and statement, that means I want the intersection, which means I want to know where they're overlapping, right? Let's go ahead and do this. So if I subtract 5 over, I'll have x is less than 4. And then if I do this other one, and remember, if you are dealing with inequalities and you multiply or divide by a negative, that's going to flip your inequality the other way. That didn't happen on this one, but it could happen on the exam. So just make sure you remember to do that, right? All right, and so then on this one, right, I've got x is less than 4 and x is less than 1. And so now I want to graph this on a number line, right? So let me just make a little number line over here. So here's 1 and here's 4. And they are open circles, right, because they don't have the equal to part. So open circle at 4. And I want everything less than it, so that's everything to the left here. And then my other one is x is less than 1, so open circle at 1, and again, everything to the left. Right? But remember, I want the intersection. I want to know, where do they overlap? Right? So where do these graphs overlap?
At 1.
Okay, so from negative infinity to 1, right, is where they're going to overlap. We can see that that's where both the purple graph and the green graph showed up. Right, and so that is going to be your answer, is negative infinity to 1. Right, and a lot of times students think if it has this and statement, that it's always going to be the stuff in between there, but that's not necessarily the case. You've got to graph it to see what you need to do there. Okay. All right, let's get down to number 17 now, because this is another inequality, but now we have absolute value involved in it. So if I have absolute value of 2x minus 5 plus 3 is less than 9. All right, so we want to isolate the absolute value first. Got to get that part by itself. So let's subtract the 3 over first. And then it's, to get it by itself, it's multiplied by 2, so let's divide by 2. All right, so those 2's will divide out. And I'll be left with the absolute value of 2x minus 5 is less than 3. Okay, so now, with any absolute value, whether it's an equation or an inequality, we've got to write down our two different statements, right? Because remember, with absolute values, we could have, the absolute value of negative 3 is 3, but the absolute value of positive 3 is also 3. So there's two ways to get to the same answer. So that's why I've got to write these down both ways. So my first one is just going to be the same except without the absolute value bars, right? So 2x minus 5 is less than 3. How would I write the other one?
Two x minus 5 is greater than negative 3.
Okay, 2x minus 5 is greater than negative 3. Right? I've got to change that number to a negative, flip the inequality sign. Okay, and the other thing we need to look at here is this symbol, because this is going to tell us whether it is an and statement or an or statement. So remember, we said less than, right, or greater. Right? So remember this little way to help you remember it. I would definitely put this down on your, the paper of notes that you are going to be bringing into the exam, because I think you'll find it will be really helpful there. Right? And so since this is a less than statement, then I know that I want the and. So I'm going to actually write the word and in between here. So I remember I'm trying to find the overlap of these two. Okay, so again, just kind of like we did above, let's go ahead and solve our inequalities. Okay, so I get x is less than 4. Let's solve the other one. I get x is less than 1. Okay, and then I'm going to graph them so I can tell what part of the graph is going to be my answer, because I want x is less than 4 and the part that is x is greater than 1. Right, so here's 1, here's 4. Okay, it doesn't have the equal to part, so it's going to be an open circle on each of these. So x is less than 4, open circle at 4, and all the stuff to the left. And then I have x is greater than 1, so open circle there, but then I want the stuff to the right. Okay, and I want to know the overlap. That is just the stuff that's in between 1 and 4. So my answer will be parenthesis, because it's an open circle, 1 comma 4 parenthesis, again because it's an open circle there. All right, if those were closed circles, then we'd use the square brackets instead. Right. Okay, question on that? Does everybody understand why? You know, if this was an or statement instead, right? So if the inequality was going the other way, right? And it was a greater, right? Then we'd be looking at, well, where do the orange graph and the green graph appear? And that would be the whole thing, right? So it would be all real numbers because it would span everything. Okay, but since we were looking for the and statement on this, right, this will be my answer there. Okay. All right, let's keep going here. That would be good to do. Make sure you review over factoring really well, all of these different types of factoring. So there's the one where we have the 4, right? So we have the 4 terms, 3 terms, difference of squares, difference of cubes. Make sure you know how to do all sorts of factoring on that. And if there's some types that are giving you, some kind of a problem, then make sure you write it down, right? And kind of work through different types of problems. Are there any specific ones? I don't want to go through all of these on 23, but if there's some specific you want to look at, let's do that. Anybody want to look at any of those specifically? David's factored out. I hear you. I'm sure you're just like, I'm mathed out. You guys are just like, I'm ready for this semester to be over, and I get that. I totally do. I just want to make sure that you're feeling good about how to do the factoring. So, all right. Well, if there's none of those that you want to specifically look through, then I guess we'll just skip those, and you can kind of look those up on, on the key or whatever if you struggle through any of those. All right, let's look at number 25. Right, and number 25, it says a window washer accidentally drops a bucket from a building that is 576 feet tall. The height of the bucket above the ground after t seconds is defined by that function, right? When will the bucket hit the ground, right? So how many seconds is it going to take to hit the ground? Well, this would be a nightmare if you were standing below this bucket. Look at how high up that is. Oh my goodness. Okay, but we have the function s of t equals negative 16t squared plus 576, right? And so when we want to know when will the bucket hit the ground, well, it tells us in there S of t, this is the height, right? And I noticed on tests and quizzes and stuff that there were a lot of students that were missing ones like this because they were like, okay, I don't know what it means by when will it hit the ground. Well, that's just saying when is the height going to be 0, right? So I'm going to take that S of t, replace it with 0. When is the height 0? Right? And then what will I do to solve something like this? There's a few different things I can do. Why is he on the building that tall dropping buckets? Well, I'm sure it was an accident, right? He accidentally drops a bucket while he's washing the windows. But I agree, that would be so bad. All right, any ideas on how we could go about solving this?
Factoring?
Yeah, you could factor it. Right? What if it didn't factor? Then what would you have to use?
Either completing the square or quadratic formula.
Yeah, right? And so it's not going to tell you on the test, like, how to solve it. You're going to have to remember, right? I mean, if it can be factored, great. That's probably going to be the fastest way to go about it. But if not, then use probably the quadratic formula is the way a lot of students like to go on this, right? So if we factor this, let's see, does negative 16, will that divide into 576? I think it will. So 576 divided by negative 16 goes in negative 36 times. So that means I'm going to factor a negative 16 out of this, right? So I'll be left with t squared minus, and when I divided that, 576 divided by the negative 16, that gives me negative 36. Right? And then I can factor, this is a difference of squares, right? So t times t is t squared. What times what is 36? That adds to be 0, positive 6 and a negative 6. Right? So then I set each part equal to 0. Well, this first part here, this negative 16, there's no t to solve for, so I don't need to worry about that one, right? But if I set the other parts equal to 0 and solve it, I get t equals negative 6 and t equals positive 6. Okay, but in the context of this problem, only one of these answers makes sense, right? Remember, t is time in seconds. You can't, can't go back in time, right, and have negative 6 seconds, although I'm sure the guy would be wishing that if he accidentally dropped a bucket from that high up, that he could go back in time. But our answer will just be 6 seconds, right, is how long it's going to take to hit the ground, because this is going to be an extraneous solution from just because it doesn't work in the context of the problem. Okay? So just make sure you know how to do these types of problems. If you couldn't factor it, or you just couldn't figure out how to factor it, even, you could go ahead and use the quadratic formula on it as well. Okay. All right, let's look at some things with rational expressions. What about number 29? All right, so you need to know how to simplify rational expressions. You need to know how to multiply and divide and add and subtract them. So let's start with this 29, and I'm actually just going to, it says to multiply and divide it, but I'm only going to do it once. Let's just divide this, right? So if I'm given that f of x is x squared minus 9x over x squared plus 3x plus 2, and I'm given g of x is x squared minus 81 over x squared plus 2x, right? And I want to divide these, right? Then I'm going to write it down this way. So I'm going to just do this little division here, right? Divided by my g of x, right? Because it would say divide, like f of x divided by g of x, right? So I know it's going to be this way. And tell us the way that we need to divide those. All right, so then these, I hope you're not too factored out here, David, because we're going to have to do some factoring here to be able to do this. But I think this is fun factoring because at the end you get to like just, you know, cancel out all these things, and so it just makes it so much more fun, right? So remember, when you're dividing fractions of any sort, right, you flip that second fraction and change it to multiplication. So I'm just going to be doing that in this next one, right? So if I factor this x squared minus 9x, I can see that that's going to factor to be, I'll just do it kind of here by it, x factors out, and I'm left with x minus 9. Right? On the bottom here, I need to try and figure out how to factor this one. Well, x times x is x squared. What times what is 2 that adds to be 3? Well, it looks like a positive 2 and a positive 1. All right, if I factor this one, that's a difference of squares. So x minus 9, x plus 9. And then again here, there's just a greatest common factor that I can factor out. Okay, and now I'm going to just write it as one big fraction. Right, so my x times x minus 9 on the top, and then x plus 2, x plus 1 on the bottom. But now I've got to flip the second fraction, right? So this x times x plus 2 is on the top now, and the x minus 9 times x plus 9 is on the bottom, right? I had to flip those, okay? And now I get to just cancel things out that are the same, right? So anything on the top that can cancel out with anything on the bottom. So it looks like I've got an x plus 9 on the top, or sorry, x minus 9 on the top, x minus 9 on the bottom, x plus 2 on the top, x plus 2 on the bottom, right? Both of these x's are on the top, so those can't cancel out. And then so I don't see anything else that will cancel. So now I just need to multiply stuff together. So x times x is x squared. And then on the bottom, you don't need to FOIL these together. You could just leave your answer and keep it in factored form like that. And that would be your answer. Okay, so there is definitely going to be factoring. You got to make sure, right, that you can do it. So, all right. Hopefully that helps remind you, though. You got to flip that second fraction. Right, and it tends to be students just forget to flip that, and they do multiply instead, and then they miss it. So just watch that closely.
Can you hear me?
Yeah.
If there were an x on the bottom, like a single one, like how you factored out the x on the top, and then it's x minus 9.
Yeah.
If there were an x outside of, let's say, x plus 1. Yeah, like that.
Yeah.
Could you cancel out the x's?
Yes.
Or would it
Yeah.
same?
So those x's, like if it was like this, then that x divided by that x, right, just makes 1. Anything divided by itself is 1, so those cancel out. Right?
Yeah, I get confused when they're like attached or taken out of something because I look at that as 1.
Yeah.
But I should separate.
Yeah, and even if it said like 3x, right, over x, those x's could still cancel out, and then you'd just be left with this 3 times x on the top, right? So you got to remember that everything is connected by multiplication. They would say like 3 times x times this, right? And sometimes it helps to just put these little multiplication dots in between, so that you remember that anything that's connected by multiplication can divide out with anything on the bottom. Does that help?
Okay. Yes, it does.
Okay,
Thank you.
you bet.
And I actually had a question about the previous one we did.
Oh, okay.
Sorry.
Yeah. What was your question?
Just how to, like, when we're looking at problems like that, how do we identify that maybe like completing the square is the best way to solve that type of problem versus the quadratic equation or factoring?
Okay, yeah, that's a good question. So let's write a couple of things over here so you can remember, so you always want to try and start by factoring. So I'm just going to put, start, well, let's see. Now, let's see, how do I want to say it? I'm going to say first try and factor, okay? So first try and factor, because it's going to be fastest if it can factor. But if you're like, I am really not able to figure out the factoring, right, then if the leading coefficient is 1, so if you had something like x squared plus 3x plus 4, right, where that leading coefficient is 1, this would be a good one to do completing the square. Because we haven't taught you how to do completing the square if the leading coefficient is something other than 1. So in 1050, you'll talk about that a little bit, what you do with that. But right now, you know, so if that leading coefficient is 1, then complete the square would be a good way to do it. But you could also do, if you're like, I hate completing the square, that's fine. You could do the quadratic formula, right? So either one is going to be just fine. It's just more of a preference. And then the last thing is if you have a quadratic, you know, where the leading coefficient is something other than 1. So let's say that we have like a 3x squared plus 5x plus 2, right? And it doesn't factor. We can't complete the square with it because our leading coefficient isn't 1, right? So then that means that we'll want to do the quadratic formula. Does that help a little bit?
Yeah, that makes sense. I forgot about the rule of the leading coefficient being 1 for completing the square, so thank you for reminding me.
Yeah, you bet. You bet. So, I mean, you can use either one, but it just seems like most people just prefer to do the quadratic formula. The only time you have to use complete the square is when we're dealing with circles. And hopefully we can get to one of the circle problems here tonight. So you can see you have to use complete the square there. But when you have quadratics like this, you could just use quadratic formula for all of them when you're solving. If you're like, I suck at factoring and I feel like I'm going to get it wrong, it'll be longer doing quadratic formula, but not necessarily, I guess, if you can't figure out how to factor it, right? That would make it really long. Way to go. All right, good question. I'm so glad you asked that. That is a really good thing to make note of and know when to use what, because oftentimes in math, that's the trickiest part. You're like, I know what to do, but when do I use these different things? All right, let's go down. Let's do one with, let's see, what time do we have here? Let's go ahead and do number 32. Let's solve this. And notice in the question here, it says, solve the rational equation. Watch out for extraneous solutions. Okay, they don't say that on your test, but it is always a good thing to make sure that you're watching for when you're solving rational equations. Okay, so for number 32, I'm going to do the B one, the one that looks a little bit harder, right? So I'm going to have 6 over x plus 4 plus 3 over x plus 3 equals 15 over x squared plus 7x plus 12. Right, now our excluded values, it's always a good idea to write down what those excluded values are. And those are what's going to make the bottom 0, right? So -4 would make the bottom 0 in that first fraction. So x cannot equal -4. And also x cannot be -3, because that would make the bottom 0 on that second one, right? And then it's always a good idea to factor this so we can see if there's anything else there that will be excluded. Well, let's see, 4 times 3 is 12, and to get 7, I'd need to add both of those. All right, so I have the same thing there that was over there. So these are my 2 excluded values. So meaning, if in the end I come up with one of these solutions I've got to remember that that cannot be an answer, right? I can't include that as one of my answers because it will make me divide by 0, which I can't do. All right, so now you're going to want to multiply everything by the LCD. Okay, let's move this a little bit easier for me. So the LCD is that x plus 4 times x plus 3. Right? And so I'm going to go ahead and multiply this first fraction by that, and multiply the second fraction by that. Sorry, it's kind of messy. And then the last fraction there by it. And then I'm going to kill the denominators. Okay, this is where you get to kill the denominators. If it starts with an equal sign in it, we can kill them off, right? Look back up here with me on the side here on number like 30, right? These don't have equal signs in them, so you have to work with the denominator. You cannot kill the denominator unless it's an equation, and that's what we have here. So we're going to kill the denominator. So I can see that x plus 4 on the bottom divides out with that x plus 4 on the top, x plus 3 on the bottom with x plus 3 on the top, and then both of these will divide out there, right? I killed all the denominators. And then what am I left with? Well, on the first one, 6 times x plus 3. The second one, 3 times x plus 4 equals 15. Okay, and be careful, this one is add already, but when this is subtract here, sometimes people forget that they've got to distribute that. You know, if this was minus, you're really distributing a -3 to both of these guys. Okay, so just watch that closely if it's subtract. Remember, you've got to distribute that negative through. All right, so let's go ahead and distribute these. So 6x plus 18 plus 3x plus 12 equals 15. So 9x plus 30, right, put those together, equals 15. Let's subtract the 30 over. So 9x equals 15, negative 15, oops, okay, and then divide by 9. So x equals negative 15 ninths. And that is not one of the answers that I came up with there, so that means that is a good solution. But I will just warn you that it seems like 90% of the time, right, on these type of questions that show up on the final, that students, forget about those excluded values, and then that is one of the solutions that you come up with, and then they leave it as part of the answer. So just make sure that you watch that closely on there. Okay, is there questions on that? I can help explain a little bit better. Oh, it looks like I forgot. We need to reduce that fraction too. Yeah, thanks, Shannon. Right? So let's make sure that we reduce any fractions there. That is one thing that, I would check in your calculator always to see if it will reduce more. Because some of your calculators reduce, fractions for you. But I can see that 3 divides into both of these, so that will leave me negative 5 on the top and then 3 on the bottom. Okay, so always, always, always reduce any fractions that you might have. Okay, and then look for those excluded values in case it comes up. All right. Okay, I want to talk to you a little bit about number 33, just because I talked about in my class, my face-to-face class, kind of a shortcut that you can do with these work problems. And if you've been to some of my reviews and stuff, you may have seen it already if you're in my online class. But let me just kind of, give these, because I think these would be some good things to put on your paper as well. So if it's something where you're trying to figure out the time that it takes working together, right, then there's a little formula that you can use that says A times B over A plus B. And if you're trying to figure out the time it takes for someone to do some, working by themselves, right, so working alone, then it's A times B over A minus B. And you just need to make sure that your A is always the bigger number. So if I'm looking at this 33, right, that first one there, a father can mow his lawn in 3 hours. His son takes 5 hours to mow the lawn. How long will it take to mow the lawn if they work together? Right? And then notice it says round your answer to the nearest tenth if needed. Watch those instructions closely. I just hate that I have to take off points when people round to the wrong place, but that's what I have to do on the final. So make sure that you're watching that closely, okay? So this is, it says when they work together. So we are going to be using this first one, right? And so I always want to put my A as the bigger number. So the two things that I have is the 5 hours and the 3 hours, right? So 5 times 3 on the top, and then 5 plus 3 on the bottom. So that's going to give me 15 over 8. And then it says round that answer to the nearest tenth. So let's divide that in your calculator. And so it's 1.875, but if you put it in like that, you're going to miss it, right? And make sure you're rounding to the nearest tenth. 7 is big enough to round that up, so I'm going to say it's 1.9 hours if they work together. Okay. Right, and again, if it was working alone, you would do the same thing, take the two numbers that they're giving you, but make sure that your A is always the bigger number, because you have the A minus B on the bottom. If you don't put the A as the bigger number, then you're going to end up with a negative answer, which we don't want to have. You can't have a negative amount of hours working. I'm sure sometimes it feels that way. It does to me, right? Like I get nothing accomplished even though I've spent so much time doing stuff. I'm like, ah. Okay. How's everybody feeling about synthetic division? Would you like to work one like number 34? Anyone? Anyone? Bueller? Okay. Let's try doing 34B, right? That second one there. So it says this, and I wanted to do this one because it gives us kind of a couple of different things that we want to make sure that we're looking for when we're doing synthetic division. All right, so first of all, what you're dividing by, to be able to know if you can use synthetic division, you have to have your leading coefficient is 1 and your exponent is 1. If that's the case, then you can do synthetic. Okay. And then look at this first one though, because this is not in descending order. And so you're going to want to rewrite that so it's in descending order. And descending order means the highest exponent first, right? So I'm going to have 2x to the third power. And then I want to do my x squared term next. Oh, but I don't have an x squared term. So I need to put a 0 in there to hold the place open for that x squared term. Then my x term comes next, and then my constant term, right? So I need to look at this because remember I'm using the coefficients of these in my synthetic division, right? Now, to set it up in the little box out here, you're asking yourself, right? So we're looking at the part that you're dividing by to figure out what number goes in this box. And we're thinking, what value for x, what would x need to be in order for this whole thing to be 0? Well, x would need to be -2, right? -2 plus 2 is 0. So -2 is the number that goes in the box there. All right, and then I'm going to put my leading all my coefficients in. So 2, 0, 3, -9. All right, now I'm going to skip a place because I'm going to be writing numbers above and below this line. Okay, so first thing you do, bring down that first number, whatever it is. So 2 comes down into my answer row here. All right, then take that number and multiply it by the number that's in the box. So 2 times -2 is -4. And then write that underneath your number next to it. All right, then go ahead and add those together. 0 minus 4 is -4. And then start it over again. Now multiply -4 times -2 is +8. All right, add those together. That will give me 11. And then 11 times -2 is -22. All right, and then add those together and get -31. So my answer, right, so I've got to remember that this last number that I come up with here in my answer column, this is my remainder. Okay? And then I started with x to the third, so my answer is going to be, go 1 down from that. So it's going to be, so I'm going to have 2x to the second. Right, so it started out as x to the third. I need to reduce that by 1. So 2x squared minus 4x plus 11. And then write the remainder as, you can write it as plus a -31 over whatever we were dividing by, that x plus 2. Right, or you could just write it as minus 31 over x plus 2. Either one will be accepted. But you need to make sure you write your answer in this form. If you just leave it like I have here in orange above, you're going to miss it, right? You've got to write it back as a polynomial again. And the remainder is always the numerator, and then the denominator of the remainder part is what we were dividing by. Okay? All right, so synthetic division, something very important to know. You're going to be using the synthetic division a ton in 1050. So I would say 95% of the time it shows up on the final exam because you have to use it so heavily in 1050. So you want to make sure you know how to do synthetic division so that you can use it in your next class. Okay. All right, let's see, we've got about a half hour left here, and let me see here. Let's go down here to number 42, because I noticed on the test also that it seemed like rationalizing the denominator, there was a lot of students that were missing that. So I'm going to do the part B on this one. So if I do the square root of 5 plus 3 over the square root of 2 minus the square root of 3. All right, so when it says to rationalize this denominator, all right, we're trying to make it so there's no square roots on the bottom. That's what that means when it says to rationalize. And the only way to do that when we have like 2 terms on the bottom is that you need to multiply by the conjugate. Right, so we're looking at the bottom. That's going to tell us, help us figure out what the conjugate is. And the conjugate of this denominator would be the square root of 2 plus the square root of 3. Right, so they look pretty similar, except one had a minus sign, the other had a plus sign. That's the only difference between conjugates, right? And then I also need to multiply by that same thing on the top. And then you can see here, okay, I need to multiply all of this with all of this, so that means I'm foiling those together, and then the same thing on the bottom. I'm doing another foil. All right, so I'm going to try and work through this with you here. So if I multiply, right, I'm foiling there, so square root of 5 times square root of 2 is square root of 10. Square root of 5 times square root of 3 is square root of 15. Right? I can just multiply what's inside together, right? If they're inside the same kind of radical, you just multiply the numbers inside there. On this one, 3 times square root of 2, this 3 is not inside a square root, so I can't, multiply those numbers inside together. I'm just going to write it as plus 3 square roots of 2. Right? 3 is on the outside, and then 2 still stays inside. And then the other one would be plus 3 square roots of 3. Right? And then on the bottom, same kind of thing that we need to do here. Right? We're going to FOIL these together. So the first multiply together, square root of 2 times square root of 2 is square root of 4. And then I get plus the square root of 6. Multiply these together, I get minus the square root of 6. And then minus the square root of 9. And now I just need to simplify the things I can. You can see on the bottom that square root of 6 minus square root of 6 are just going to cancel out. And I can also see the square root of 4 is 2, and the square root of 9 is 3. So I really have on the bottom there 2 minus 3, right? Which is just going to be a negative 1. Now, when you look on the top, there's nothing that I can add together, because remember, when I'm adding square roots, I have to have this stuff inside the square root the same. And I've got a 2 inside that one, a 3 inside this one, right? 15 and 10. I mean, I'd want to simplify them if I could, but none of these will simplify anymore. And then combine those together. Right? And so my top is just going to stay just like it is, and then we're dividing it by a negative 1. But when I'm dividing this all by a negative 1, it's really like I'm dividing each different part by negative. So it'd be negative square root of 10 minus square root of 15 minus 3 square roots of 2 minus 3 square roots of 3. And so that is as simplified as we can get this. So that would be our answer. All right. Oftentimes there's going to be things that you can combine together, though, on it. So make sure you're looking to see if there's anything you can combine together there. Okay. All right. Let's look at solving a radical equation also. This tends to be something that students struggle with and usually need to know how to do. So 43, remember, on any of the questions that say solve, you can always, right, you can always check your answers by putting it back in. So that's always a good thing to do, especially if you have some time left over on the test. All right, so to solve something that has a square root in it, we want to figure out how we can get rid of that square root, right? So we're thinking, how do I undo square rooting something? And that would be squaring it, right? And if I square one side, I need to square the other side as well, right? So square root and the square undo each other, and so I'm just left with 9 plus x on the left-hand side. But on the right-hand side, I need to FOIL these together. This is really saying x plus 3 times x plus 3. And a lot of times people forget that they're FOILing there, and they just try to distribute that 2 through, but that's not going to give you the same answer. Got to FOIL. So when I FOIL that, I get x squared plus 3x plus 3x plus 9. All right? And now I see, okay, I've got an x squared. And so the way I solve something that has an x squared in it is I need to get everything over to one side so I can set the other side equal to 0. So let me combine some like terms here on the right-hand side. So it would be x squared plus 6x plus 9. And then I'm going to move that 9 over. So I'm going to subtract the 9 over. I'm going to subtract the x over. All right, so that's going to give me 0 equals x squared plus 5x. All right, and there's no numbers left there, right, on that third term, and that's just fine. And then I want to see if I can factor it from here, right? And oftentimes these are going to factor, but again, if you're like, you know, struggling to try and figure out how to factor them, you can use the quadratic formula on that because you have a quadratic set equal to 0, right? But let's factor this. The greatest common factor is x. That leaves me with x plus 5. And that's all I can do with factoring it. So I'm going to set both parts equal to 0, x equals 0, x equals negative 5. Right? And so those are the two answers that I come up with, but you always want to check these because these could have extraneous solutions too if there's a square root, okay? Meaning one or both of these solutions might not be good. So let's check them over here and make sure they both work. So if I put 0 in the first one, so square root of 9 plus 0 equals 0 plus 3. Well, square root of 9 is 3. So 3 equals 3. So that one does check out. Let's try the other one. So square root of 9 minus 5 equals negative 5 plus 3. So here, it's square root of 9 minus 5. So 9 minus 5 is 4. Right? And negative 5 plus 2 is a negative, or negative 5 plus 3 is a negative 2. When I take the square root of 4, I get 2 equals negative 2, which doesn't work, right? So that means that this negative 5 that I came up with for an answer is an extraneous solution, and the only answer I want to give on the test would be this x equals 0. Okay. All right. Hopefully that helps on that one. Okay, and then it looks like, make sure you know the distance formula, make sure you know the midpoint formula. Those would be good things to make sure you have on the test. Also the Pythagorean Theorem, right? How to solve things with the Pythagorean Theorem would be a good thing. We had a request to look at some of these down here with the form of a plus bi. So let's look at number 47 because that actually will give us a few different things to look at there. It envelops a lot of it. So with this one, it's telling us to multiply, right, two complex numbers together. So 3 minus 4i times 6 plus I. Right? And you can see that this looks the same way as when we're foiling things, and that's exactly what we're going to do there. Right? But before we foil those together, two other things that I want to make sure that you put on that little sheet that you're bringing into the test is to remember the square root of negative 1 is I, and I squared is negative 1. Right? These are so important to know in order to simplify this. Okay? So let's go ahead and look at this. So if I FOIL this, 3 times 6 is 18. 3 times I is plus 3i. Then negative 4i times 6 is negative 24i. And negative 4 times I is negative 4i squared. And this is where a lot of people made mistakes with these i's, is forgetting that that I times I is I squared. Okay? And then remembering, oh yeah, I squared is negative 1. So wherever I see that I squared, I'm going to put a negative 1 in place of it. Right? So Let me write down the rest of this a little bit here. So this is going to say negative 4 times that negative 1. All right, I can combine these i's together on that. So 3i minus 24i gives me negative 21i. And then I still have that 18 there. Okay, so when I write this down again, I've got 18 minus 21i, and then negative 4 times negative 1 is a positive 4. Right? And then, remember, I want it in the form of a plus bi, so my I part needs to go second. So I'm going to go ahead and add my 18 and my 4 together, because those are like terms. So 22 minus 21i. And now it's in that form that we need. Okay. Let's see, 47b. Do you mean the one that says square root of negative 3 times square root of negative 7? Since there's 4 of them on there. Okay, yes, let's look at that one also. Okay, so on that next one, right, so what do we do with something like this? So square root of negative 3 times square root of negative 7. Well, you have to change these to i's before you can multiply these together. Oftentimes students like try and multiply that together and think, oh, that's the square root of 21. But you can't do that because we've got negatives inside the square root, which are imaginary numbers. So we got to change these to imaginary numbers first. All right, so remember this first one could be written as negative 1 times 3. And the second one is negative 1 times 7. So remember, the square root of negative 1 is I. Right? So I'm going to change this so that negative 1 basically gets to come out as an I. Right? But then 3 is still stuck inside. And then on this one, again, that square root of negative 1 comes out as an I, and the 7 is still stuck inside. Right? Now let's multiply these together. So I times I is I squared, and then 7 times 3, right, it's going to give me the square root of 21. And then, again, I've got to remember that I squared is negative 1, right? So now I need to replace that I squared with a negative 1. So negative 1 square root of 21 would be my answer on that. Okay. Does that help on that one? 47. Okay, let's take a look and see if we have a few others here that we want to look at. Let's look at some circle ones, because a lot of times circle questions are asked on this too, because again, in 1050, you're going to be talking about circles, but you're also going to be talking about other conic sections like ellipse and hyperbolas. So they want to make sure that you understand the basics with circles before you move into 1050. Okay, so let's do one. Let's do 50 here. Right, so it gives us something in general form, and we want to change that so that it is in standard form. So let me write this down really quick here. And it wants us to find the center and the radius, right? But we need to change it to standard form in order to do that. So we need to do complete the square in order to change this to standard form. Okay? And so first thing that we're going to want to do is we want to add that 27, whatever that constant term is, get it over to the left side. Okay? And then we're going to want to group our x's together. So I'll have my x squared minus 4x plus blank, right? Because I'm trying to complete the square here. So I need to leave this open so I can make this into a perfect square trinomial. And then I want my y's together, so plus y squared minus 6y plus blank, right, equals We've got 27 over there already, right? So 27, and then plus the orange blank, and plus the green blank, right? Whatever I add to one side, I've got to add to the other side as well. All right, now we got to figure out what goes in those blanks. Well, we do that by taking half of the middle term, right? So that middle term, so that -4, we'll divide it by 2 and then square it, right? So that's -2 squared, which is +4. So I'm going to put 4 in this blank and in the blank on the right-hand side. Now let's do the same thing for our y's. Take half of that 6 and then square it. Right, so that's -3 all squared, which is +9. So remember, that's saying -3 times -3. Negative times negative is a positive. Right, and then put 9 in the other blank. All right, so then for my x's, right, that perfect square trinomial, this is going to factor to be x minus 2. It's always what half of this middle term is, right, what this is, all squared. And then my y's going to factor to be y minus 3. Again, half of that middle term, all squared. And now I need to add these three numbers together, right? So I need to add my 27 and my 4 and my 9, and that will give me 40. Okay. So my center I'm going to find by looking at this orange and green part. Right? So the center is going to be the opposite of these, right? So even though it says -2 in there, x is going to be 2, and my y is going to be +3. So you always have to do the opposite of those. And I've said before, some of the things when I teach, that insiders are liars, right? So when they're inside parentheses like we have here, we've got to do the opposite of what it's really saying. And then the radius is going to be the square root of 40, but you'd want to see if you could simplify that. Again, on the last test, a lot of people missed it because they just didn't, factor this out and stuff, right? So I can see, all right, 40 breaks down in my prime factorization to 2 times 2 times 2 times 5, right? And so I can see that a 2 gets to come out, and then 2 times 5 is still left inside. Right, so 2 square root of 10 would be what I'd want to say my radius is. Right? If you leave it as square root of 40, you're going to miss some points there. Make sure you simplify. Okay? Or look to see if it asks you to write it as a decimal. And if it asks you to write it as a decimal, then round to the place value that it is giving it, that it's telling you to round to. Okay? All right, let's see what else we have here. We've already done some stuff with the quadratic formula, but maybe let's go down here to number, let's do 58 and 59. These are both important ones to look at. So 58 is asking you to graph this, but it also is asking you to find some other things, right? So we're going to want to find the vertex, we want to find the y-intercept, and we want to find the axis of symmetry. Okay? And so remember, when you're finding the vertex, it's always a good idea to, have that vertex formula and know, what the vertex formula is. So to find the vertex, you'll do, to find the x value, -b over 2a. Right? And so -4 is my b, so the opposite of that b is going to be +4 over 2 times my a, which is 2. So 4 over 4, which is 1. Right? So my vertex, I know my x value is 1. Now I need to go and find my y value, and I do that by substituting that in. I'm going to put this 1 back in place where those x's are, right? So to find y, I'll put 2 times 1 all squared minus 4 times 1 minus 1. Right? Make sure you use the order of operations, or maybe your calculator will already do that for you, right? So if I have this, I'm going to do 1 squared is 1 times 2 is 2 minus 4 and then minus 1. So negative 2 minus 1 gives me negative 3. So my vertex is at 1, negative 3. Right? To find my y-intercept, I'm going to always define intercepts, right? To find the y-intercept, I'm going to let x equal 0 and then solve for y. This would be another good thing to put down. How to find x-intercepts, how to find y-intercepts, right? So to find the x-intercept, I'm going to go back to this function and put 0 in place of my x. So that's going to give me 2 times 0 squared minus 4 times 0 minus 1, right? And this is what my y equals. So I can see, well, that's just going to be 0. That's just going to be 0. So I'm really just left with y equals negative 1. But when I write my answer down, I need to write it as an ordered pair. Right? Got to write it as a point. And on this, I said x was 0. So in place of my 0, or in place of my x, I'll put 0. And then my y is negative 1. Okay? And then my axis of symmetry can always be found by looking at whatever the x value is, right, on my vertex. So I'm looking here, right, and I got to write it as an equation. That's where some people make mistakes too, is I need to say x equals 1, because that is an equation. Because let me show you now with the graph. Let's graph some of this so we can see. So my vertex, so over 1, down 3 is going to be my turnaround point of my parabola, right? It's a positive 2 in the front, so that means it's a right side up parabola. And see, my y-intercept is at 0, negative 1, so over 0, down 1 is there. And I can see my axis of symmetry is here at 1, right? And so that is, that's where I'm going to fold it over, and they're going to be exactly the same, right? And so I could say that I know that there's another point right here, because I went one direction, one place from the axis of symmetry to the left, so one place in the axis of symmetry to the right is going to be another point on that graph. And then that's enough to be able to see what that is going to look like. And if it asks you to find x-intercepts, right, that means you'd have to let y equal 0 and then solve for x. So that's usually where you're going to need to use the quadratic formula if it asks you to find x-intercepts. Oops. Okay. All right, let's look at 59 also. I know you guys are probably getting really tired and like, oh my gosh, it's 9 o'clock, right? But I want to just, talk a little bit here about this. I'm not going to work through all of these different parts, but I want to make sure you understand what to do on this type of story problem, right? So it gives you, right, this function, and it asks you a few things about it, right? So A, how long after the object is thrown will it be 100 feet from the ground? Well, this is an upside down parabola, and I can tell that because my leading coefficient is negative, right? So I know it's kind of a parabola that looks like this. And this 200 here means that's where it's starting to be thrown, right? So here's 200 feet in the air. That's actually where it's starting to be thrown. and then at some point, right, it's going to be reaching 100 feet here, and so we're trying to figure out when is it going to be 100 feet. Well, it gives you the height, so you're going to put that 100 in place of h, and then you're solving it from here. Right? And so we need to get everything over to one side and put it equal to 0. And then from here, you're going to want to use the quadratic formula. Oops, it should be 100. Try to subtract that. All right, so I'm going to know that my A is negative 16, my B is 12, and my C is 100. Right, and I'm going to use the quadratic formula. I'm not going to put that all in there. That's going to take a little bit of time there, right? So this is part A, right? When is it going to be 100 feet off of the ground? Part B says, when will it hit the ground, right? Well, here is my ground, and here is where the height is 0 feet. So that's what I'm going to put in place of h this time. And then, again, use the quadratic formula. Or you could try and factor it, see if it will factor, but a lot of times these don't. And so a lot of times students will just, go and use the quadratic formula on that. Okay. So on this one, A is negative 16, B is 12, and C is 200. Right, but we'll still use the quadratic formula on that. But the part I wanted to make sure I got to is this part C, where it's saying, what is the maximum height? Right, so I'm going to have a vertex up here, right, which is the highest point of this, which is going to be my maximum. And that's what I'm looking for, is that turnaround point, or the vertex. So whenever it asks for max or mins, right, maximums or minimums, you're going to find the vertex. Okay, and it seemed like on the test some people were getting confused whether, they needed to find the vertex or whether they needed to use the quadratic formula to solve it. Okay, and so then you'll use the vertex on there. Oops, let's see, I'm just going to go here. So we'll say negative b over 2a. Right, is going to be what my t is. So negative 12 over 2 times negative 16. Negative 12 over negative 32. And that's going to end up giving you a decimal answer there. So, or, you could reduce the fraction 2 on it, and that would be, let's see, if we did 4 divides into these, so 3/8, or you could use the the decimal. Yes, right, and it doesn't matter which answer you put in unless it specifies what to, like, and oftentimes on this it will say round to the nearest tenth or something like that. Okay? And then you're going to use that answer to figure out what the height is by putting that back in. Right? And so, because that's what we're trying to find, what is the maximum height? So this isn't our answer, we've got to plug that back in. So we'd have negative 16 times 0.375 squared plus 12 times 0.375 plus 200, right? And then simplify that all up to figure out what the height of that is going to be. Anybody have that done? Yeah. What am I doing again here? 59. So I think it's 202.25 feet. Okay. So that, 200 wasn't too far off of where it started. right? Gets to that maximum and then turns back around. Okay. Make sure I did that one right. Anybody do it on there? All right, pretty sure that is right. Okay. And then maybe we're going to be going over just a few minutes here, but I think it'd be really good to go through just a couple more on this last one since, you know, Module 8 you haven't had a quiz on. So let's look at just a few of these. If we look at number 62, right, and it wants you to find the inverse. And I'm going to look at the second one, the part B one, if you will. All right. And so if I want to find the inverse of this, right, there's 4 steps that you're going to take. You're going to change, right, your g of x to y, or f of x, or whatever that gives you for that. So we'll have y equals 3x minus 1 over 4. Then you're going to switch your x and y. So I'll have x equals 3y minus 1 over 4. And then the third step is I'm going to solve for y. So this is where it gets kind of tricky with these fractions. Sometimes people are like, what do I do here? Right? But remember, this x is over 1, so I could kind of do like cross multiplication again. So I'm doing, you know, or think about, well, maybe a better way to think about it is to get rid of that dividing by 4, I'll times both sides by 4, right? So I'll end up with 4x equals 3y minus 1. To get y by itself, let's add the 1 over, and then divide by 3. And then the last step that a lot of people forgot on the week 11 review is that you've got to write this in the form. So you've got to change your y to the inverse form. So I'm going to want to write it as g to the negative 1 power of x, right? So this means the inverse of x. So g to the negative 1 power of x, or the inverse of g of x, is 4x plus 1 over 3. And that's how I leave my answer on that one. Okay, are there questions on that? I realize some of you might have to go, but I was going to work out just a couple more here. Let's look at I wanted to do 64 and then 66. I find these really helpful. So 64, we have 4 to the 3x minus 6 power equals 16 to the 2x power. We want, when we have something like this, we want to have the same base. Right? We need to get those bases to be the same so that we can set the exponents equal to each other, was the thing that we talked about there. And to get the same base, some people kind of got confused on how to figure out what that is going to be. We'll just do, figure out what the prime factorization is of these, and that will help you to figure out what this is, right? So 4 is the same thing as 2 to the 2nd power. 16 is 2 to the 4th power. Right? And then they'll have the same base. They'll have that same base of 2. So 4 is 2 to the 2nd power, but then I can't forget that I still have to multiply that 2, right? Distribute that 2 through that 3x minus 6. Right? And then on the other side, 16 is the same thing as 2 to the 4th power, but I still need to multiply that 2x and 4 together there, because that 2x was already up there. Okay? But now that our bases are the same, all we have to do is set the exponent parts equal to each other. And I'm going to go ahead and distribute this through before I bring it down here. So 2 times 3x is 6x minus 12 equals 4 times 2x, which is 8x. So let's just solve this for x now. Negative 12 equals 2x. We'll divide by 2. X equals negative 6. And that will be my answer. And you could always check it. Remember, whenever you have instructions that say solve, you put this back in and do the check on it. Okay? Yeah, Nydia, I'll go back to that after, if you can hold on for just a minute, okay? And I'll go back and explain that one that you want to look at the end. But let's look at one more here. Let's look at number 66. All right, and with 66, I want to talk about both of these a little bit. They won't take very long to do, but I just want to make sure it's clear, all right, what we're doing here. So in order to solve something, whenever there is, you're solving a log, right? If you get stuck on any of your log questions, I'd always say try and change that to exponential form, because you're usually going to be able to figure it out if you get it into that form, right? So this would be 2 to the 5th power equals that whole thing, that 3x plus 1, right? And then I could solve that for x. However, on this one, sometimes students get a little bit stumped by it because there's not a base here. But remember, this is the common log, so if it doesn't show a base, that is a base of 10, right? So you're doing 10 to the 2nd power equals this. All right, so 10 to the 2nd power is 100. And then I'm going to add 3 over. So 103 equals 5x, and then I'll divide by 5. So x equals 103 over 5. And then if that could reduce, you'd want to reduce it, right? Or if it says to keep your answer, change your answer to a decimal, then do that, okay? All right. And with any of the graphing ones, remember that you can always make a little chart, right? And with most of the graphing on there, you're going to be picking your x's, finding your y's. But when you're graphing logs, right, you've got to remember that you're picking your x's, picking your y's and solving for your x's, because you're going to change it to exponential form. Okay, so again, it's always a good idea when you're dealing with logs, try and change them to exponential form, because usually you're going to be able to figure it out from there, just because you're just more used to exponents than you are logs. Okay, well that's, I think, we've went over a few minutes here and stuff, but I hope you found that really helpful. I think the things that we went through tonight will really help you on the final. Go back through the review and make sure that you're understanding the different concepts from the different chapters and stuff. And then if you have some questions, please reach out to me individually. I'm more than happy to help you work through a problem or something like that if you cannot, figure out how to do it. That's what I am here for. So please, please, please reach out to me, and I would love to help you, okay? If you have any other questions, stick around, and Nydia, I will go back to that one that you wanted to look at right now too. Okay, was it number 62? You're welcome, guys. Thank you. Okay, so I'll just go back through. So I was talking about how when you're finding the inverse, there are 4 steps that you need to follow, right? So the first step is you need to change your g of x or f of x to y, right? After you do that, you're going to switch your x's and your y's. Then you're going to solve for y, and this is usually, where the most difficult part of, I guess, finding the inverse is, right? And so in this one, since my 4 was on the bottom, right, and I'm trying to get the y by itself, in order to undo dividing by 4, I multiplied by 4 on both sides. So you can see that's what I did with the orange. Right, multiplied both sides by 4, which will leave me 4x. Right, these 4's canceled out. Right, so the reason why I did multiply by 4 so I could get rid of that, and then leaves me 3y minus 1. Right, on the right hand side. And then I'm just trying to solve for y. Get y by itself. Add the 1 over and then divide by 3. But the last step is that you need to change, right? So you got this y equals this stuff, but you can't leave your answer in that way. You've got to change your answer to showing that it is the inverse. So that's why I wrote the answer as the inverse of g of x equals that 4x plus 1 all over 3. Okay, did that make sense, or is there a specific part that you want me to explain more? Okay, you got it now. Awesome. Awesome, awesome, awesome. Just remember, I would write down those 4 steps in your notes too, like finding an inverse. These are the 4 steps. Okay, I think that will really help if you can write that down on your sheet of paper that you get to take in also. Okay. All right, anything else? Let's see, Melissa and Shannon, you're still on too. Did you guys have some questions that you wanted to specifically ask me about? I'm more than happy to go through them.
I just had a question about, I had sent you an email saying that I was not going to do the in-person test, but I decided to go ahead and do the in-person test. Okay. So do I just go ahead and go? I don't need to change anything.
Yeah, if you,
they'll have my test there.
If you didn't contact anybody in the math department, like I don't have any power to change anything with that, so you would have had to contact somebody there. So if you didn't do that, then you are still set for it, and you can still go at the time that they gave you. And yeah, and then like I said, yours is going to be a paper test, but you know, it's going to be similar to the ones they're doing online. It's just yours is going to be on paper, and then they'll give that to me.
Sounds good.
Okay.
All right. Thank you for your help.
You're welcome. Let me know if there's anything else I can help you with. Okay.
All right.
Okay.
Thanks.
Yeah. All right. And Shannon was good. She left. All right. Nadia, is there anything else?